This week, I'm going to push your limits of technology just a little bit. While on my travels to Washington, D.C. this past week, it allowed me to do a little bit more research on a technology I first saw at the Kennedy Space Center. The piece of technology is called tissue chips.
Thanks, Chad. Great to meet you down in Florida. So I'm Lucy Lowe. I'm a tissue chip program manager here at the National Center for Advancing Translational Sciences, or NCATS, which is one of the institutes and centers at the NIH. So we fund the development of these small devices, which are called tissue chips. So these tissue chips are tiny devices that house human living cells in a three-dimensional structure in a way that model the architecture and your tissues and your organs in a very realistic way. So right now, drug development, which can take a really long time and is extremely expensive here on Earth, relies on two-dimensional cell cultures very often and animal models. And in case you hadn't noticed, you are neither two-dimensional nor are you an animal. So we need really good models that faithfully recapitulate and emulate human tissues in a way that means we can test drugs and understand disease without actually testing them in humans or in animals. So this is a lung chip. This is actually modeling your lung. It has your lung alveolar cells on one side and your lung epithelial cells on the other side. So it models the air-liquid interface of your lung, and it has special built-in biomechanical forces that can cause those tissues to expand and contract, just like the stretch and relaxation that happens in your lung every time you inhale and exhale. So this is one of our developed chips. And so we've partnered with NASA and the International Space Station National Lab to send these to the space station. And the reason for this is because there are changes seen in astronauts that are very similar to a lot of diseases that we see down here on Earth, but they happen on a very fast timescale. So we can model diseases and test drugs in these systems in microgravity at a very short timescale and look at things that could take decades for us to look at here on Earth. So that's why we've sent them up to microgravity.